Well, hello and welcome to 4-H Computers. This is session one, dawn of a new era. We're going to start off by asking a question. What is a computer? Well, a computer is like an assistant that can help you solve problems or do some of the work that you would otherwise have to do for yourself. But it's a robot assistant. It's a machine, not a person. So it's going to act in some ways a little different from a person, and in some ways, maybe even better than a person. So, what is a computer program? A computer program is the instruction list that you give to your robot assistant. It can be a really complicated list of orders to do, or it can be something pretty simple, like going to the store and buying an apple. So that's what a computer program is, a list of orders for your robot. But once I've given my robot a complicated program, a task to do for me, maybe that it does it every day. Maybe I live on a farm and I want my robot to harvest fruit for me, and I've given it a program that lets it go out and harvest whatever fruit I want that day. Um, but I don't want to have to rewrite the program every day. So the first thing that my robot needs to be able to do, or any computer program, is listen. In other words, get information from the outside world. A calculator wouldn't be very useful if it always calculated the same expression every time. What makes a calculator useful is you can say, add up, 3 times 7, right? Or 10 divided by 5. You have to be able to give it some information from the outside world. Maybe you have a self-driving car and you have to tell it, I want to go to San Francisco or something like that. Or I want to call my friend. Or maybe you're playing a game and you want to say, I want to shoot that enemy over there. These are all ways that a computer program can listen. So listening is a very important skill for a computer robot to have. But telling your computer assistant what to do is only useful if you can get some information back out. Telling your calculator, 7 times 10 doesn't do anything unless it can show you 70 as the result. Similarly, your self-driving car isn't going to be very useful unless it actually takes you to your destination. And your computer game isn't going to be much fun if it doesn't show you what happens when you actually shoot the enemy. So these are various ways that a computer can talk to the outside world. I'm using listen and talk as general descriptions of input and output because that's how human beings tend to communicate with each other. But there are lots of ways that a computer can listen or talk. You might want to think about some yourself. For instance, typing on a keyboard is a way that a computer can listen to you, or moving a mouse, maybe. But your computer assistant isn't going to be very useful if it doesn't understand what you're saying. If you have a personal assistant who only speaks Swedish and you only speak English, your assistant's not going to be very useful because no matter how brilliant and capable and fast and strong your assistant is, if it doesn't understand what you're asking it for, it's just not going to be much help. I wanted to get a loaf of bread and I got shoe polish instead. It's not very helpful. So a computer must have a language that the programmer knows that allows you to communicate your orders to it. But that said, a computer has to be able to sequence a list of instructions. That is to say, to step through a list of orders. Like if I tell my robot to go outside, open the gate to the garden, pick 5 tomatoes, close the gate, get back on the tractor, uh, uh, cut down the hay, and then return home. The computer has to be able to do those in order. it can't just keep executing the same step over and over again. It's got to be able to go through a list in order. Now, this is a pretty simple task for a human, but for a computer, you've got to kind of build it so that it knows how to do this. Similarly, a computer needs to know how to evaluate a mathematical expression. Computers are very good at math. You can solve a lot of complicated mathematical problems with a computer that might be almost impossible to do without a computer. Computers are very fast at this. But even if your robot assistant is doing something as simple as buying a few items at the grocery store, your assistant would still need to be able to do basic math like adding up how many things to get and what the price of those things might be. You got to add up the cost. So being able to evaluate mathematical expressions is an important capability that every computer has to have. Just two left. One of them is remembering. We kind of take this for granted as people, but if I tell my robot assistant to go out, if its program tells it to go out and collect vegetables from my garden and bring them back to me, and one day I say I want 7 tomatoes. If it's going through the garden and picking tomatoes, and it's already picked 5, it better know that when it picks the 6th one that it already has 5, because otherwise it's not going to know when to stop, right? The computer needs to have some memory of what it's done before to do any kind of a sophisticated task. Try doing something at home without using your memory. You'll find that almost any task is impossible without using some amount of memory. But again, for computers, nothing comes for free. We have to make it ourselves. And finally, computers have to be able to choose between 2 paths of action. This is something that we as people do pretty instinctively, but a computer has to be taught that sometimes it should do one thing and sometimes it should do something else. For instance, my farm assistant goes through the garden and it picks tomatoes, then it finds another tomato, and then it finds another tomato, and it just keeps finding tomatoes until it has 7 tomatoes, because that's what I told it when it was listening to me in the beginning. So when it has 7 tomatoes, it has to do something different, which is to bring them back to me. So at that point, it has to choose, do I go pick tomatoes or do I return them to Dave? And the answer has to depend on, well, how many do I have? So computers must be able to choose a different path depending on other circumstances. So those 7 things might be a little tricky to remember. I came up with an acronym. I think you're just supposed to do this when you make a class. You make silly acronyms that hopefully will help people remember these things. I don't know if it's helpful to you, but it might be. Cluster, choose, listen, understand, sequence, talk, evaluate, and remember. If you find that useful, great. If you don't, oh well. So let's go over a simple program here, and then we're gonna find out what it actually does, and then we're gonna see how it uses these 7 things that we talked about in cluster. So here's a very simple program, and if you want to figure out what it does before I tell you, go ahead and pause the video and I won't say anything for a few seconds, and then you try to figure out what it does, and then restart the video. Okay, hopefully you had time to pause the video before I spoil the answer. But basically, as you can see on line A, the first thing this program does is it sets a sum to 0. The fact that it's called sum is kind of a hint that I'm going to use it to add things up, right? So the next thing it does is it reads a new number from the keyboard, and then it adds that number to sum. And then if the new number isn't 0, it jumps back to B and reads another number from the keyboard, and it just keeps doing this over and over again. And then finally, if the new number is 0, then we skip down. We don't jump back to B, we skip down to E, and we print out the sum. So you can probably tell from the English description that this program adds up a bunch of numbers that you type in and then prints them out. So my question for you is, clearly the program has to understand, right? It has to know words like set and read and add and if and jump and print, right? So clearly I had a computer language in mind when I wrote this program. So clearly our computer would have to understand. Also, there's A, B, C, and then D, and then jumping back to B, then E. So clearly, the computer has to sequence, right? It's got to do A, and then it has to do B, and then it has to do C, and then D. It has to do everything in the right order. So clearly, this program has examples of understanding and sequencing. But there are 5 other things in our little cluster. We still have choose, listen, talk, evaluate, and remember. So pause the video if you want to try to figure out where in this program we choose, listen, talk, evaluate, or remember. And I'll give you a little bit of time before spoiling it. All right, hopefully you had time to pause the video. So you could probably guess that we listen on line B, right? Because that line B is where we get information from the outside world. We read a new number from the keyboard. So far, so good. Now, where do we evaluate? Well, we evaluate on line C because we're adding the new number that we got to sum, right? We're evaluating a mathematical expression. That's an important thing that every computer has to be able to do. Now, what about remembering? Well, we're remembering in 2 different places. One of them is the line we just mentioned. When we say we're adding a new number to sum, it's important that we remember what sum was, right? Like if we've added 7 numbers and then we add an 8th number, we better remember what sum was when we added the 7th number. If we just keep forgetting what sum is, we're not going to be doing anything useful. So that's an example where we have to remember. And then finally on line E, when we print the final total, the final sum, we have to remember what sum is then too. So I put C and E as examples of remembering. Okay, where do we choose? This is kind of one of the more interesting ones. The answer to that is on line D, because we say, and the key to look out for is that if, right, if the new number is not 0, then we jump back to B and start the loop again, right? But if it's not, that's if the number is not 0. If the number is 0, then we don't jump back. We go on ahead to line E and print out the final answer. So that's where we choose, okay? And then finally, we talk on line E by printing out our answer so the outside world can see that we've actually done something and not just been, sucking our thumb for 5 minutes. Okay, well, that completes our first video here, and looking forward to seeing you in the next video for session 1. So long for now.